Hello, today we're going to learn about the Pythagorean Theorem. But before we start learning about that, we need to know some background knowledge to help us along the way. The first thing we need to know is addition is the opposite of subtraction. So like in this example, if I had x plus 7 equals 10 and I wanted to solve for x, I know I'd have to undo addition by subtracting. So I would do minus 7 to cancel it out on that side. And whatever I do to one side, I have to do to the other side. So that would leave me with x equals, and 10 minus 7 is 3. Next, multiplication is the opposite of division. So let's say I had 2x equals 8. I know I can undo the multiplication by dividing, because they're opposites of each other. So I would divide by 2 to cancel out those 2's and be left with x. And then it's an equation, so I have to keep it balanced. So I would do the same thing to the other side. I would divide by 2. 8 divided by 2, I know equals 4, so that would leave us with x equals 4. Next, we know squaring a number is the opposite of taking the square root. So we undo squaring a number by taking the square root. And remember, the square root looks like that. It's called a radical, and that's the square root. So if we had x squared, the way we would get rid of that would be to take the square root. So in these examples, I have x squared, and I got to figure out what just x is. So I know that we just talked about that squaring a number is the opposite of taking the square root, and we undo squaring a number by taking the square root. So if I have x squared, I undo it by doing the square root. And whatever I do to one side, I have to do to the other side. And the square root of 64 is 8. In my next example, I have x squared, so I have to take the square root. The square root of x squared gives me x. And then I have to do the same thing to the other side to keep it equal. The square root of 36 is 6. In my next example, the same thing. I have x squared, so I have to do square root to get rid of that squared and get stuck with x. And I have to do the same thing to the other side, and the square root of 196 equals 14. In my last example, I have x squared, so I have to do square root, just so I can get x by itself. And then I have to do the same thing to the other side to keep it balanced. So I'm going to do square root to the other side to make sure it stays equal. And the square root of 400 is 20. Alright, so now that we have that information ready in our mind, we can start learning about the Pythagorean Theorem. So the Pythagorean Theorem is for right triangles. So a right triangle has one of its angles being a right angle, or a 90-degree angle. And it's usually shown by this little box that I drew in green here. That little box shows us that this angle is 90 degrees. And that 90-degree angle lets us know that this is a right triangle, and the Pythagorean theorem only works for right triangles. There are 3 important parts to a right triangle. The first one you want to label is called the hypotenuse. The hypotenuse is the longest side of a triangle, and it's also the side that's across from the right angle. So if we find our right angle, we know the side that's across from it is called the hypotenuse. And in the Pythagorean theorem, that is called side C. That is C. The next important parts that we have to label are called the legs. The legs are the other 2 sides of the right triangle. So we have 2 legs. And in the Pythagorean theorem, those are called A and B. The legs of a right triangle, they are the ones that touch this right angle. So see this right angle sign here in purple that I just outlined? The leg, the A and B, are touching this right angle. So this leg here is side A, and this is B. There's 2 legs that touch the right angle. Alright, the Pythagorean theorem, we said, only works for right triangles. And the theorem is a squared plus b squared equals c squared. So what that means is one leg squared plus the other leg squared equals the hypotenuse squared. And the hypotenuse is the longest side. So that means if we take the square of the 2 shorter sides, it will tell us the length of the longest side. Alright, we can prove the Pythagorean theorem works with this example over here on the left. So this is a right triangle. I can tell by the right angle sign right here in the corner. And then what I'm also going to do is I'm going to fill in the sides of this right triangle. So this is my leg, because it's touching the right angle of the right triangle, and it says 3. So I'm going to color all these one color. Alright, so I colored those in green and I can see 3 is my leg, and 3 squared means 9. So I should have 9 green squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 green squares. I'm going to color in this side with a different color. I see this is 4. This is also my leg because it's touching this right triangle, this right angle. So I know that's going to be B. I'm going to color this side in red. And I know it's 4 squared, so I should have 16 squares. So I colored those in red. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares on that side. Alright, so the Pythagorean theorem says this side, this A side, or A squared, plus this red side, or B squared, should equal the longest side, the hypotenuse, or C squared. So what I'm going to do is I know I have 9 green squares, so I'm going to color in 9 green squares on this C squared. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know I have 16 red squares that should fit in the C squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know now that 9 plus 16 equals 25. And what is the square root of 25? That is 5. And that is what they labeled as C, our hypotenuse. So we know that A squared plus B squared equals C squared, or 9 plus 16 equals 25. Alright, here's a cool water demo that shows that A squared plus B squared equals C squared. So we have our two sides here, our two legs, A and B, that she filled with this blue water, this blue dyed water. And then when you combine those two, we can see that it combines and makes the C squared, or the hypotenuse squared. And we can know it's the hypotenuse because here's our right angle and it's the side across from it. So those two legs added together made up that hypotenuse squared. And we can see that C squared, if we divided it back up into the two legs, equals both of the other legs. So A squared plus B squared equals C squared. Alright, so how do I solve the Pythagorean theorem? First thing I want to do is write my equation, write my theorem. A squared plus B squared equals C squared. The next thing I want to do is label my triangle. So I know the side across from the right angle is my C. And then I can plug it into the equation. I don't know what it is, so I'm just going to keep it as C squared. And then I want to label my A. So I can know that A and B touch this right angle. So that would be A, and I know A is 4 now, so I'm going to plug that in for A, 4 squared. Then I want to label B. B is my other leg, the other side touching the right angle, and I can see that's 3, so that's 3 squared. Now I can start to simplify and solve for C. So I know order of operations, or GEMDAS, tells me I have to do my exponents before I can add. So I have to do 4 squared, which is 16, and then I can do 3 squared, which is 9, and then I can bring down my plus sign. I still don't know what C squared is, so I just bring that down. Now, after I squared, I can add 16 plus 9 equals 25. So 25 equals C squared. But I'm not done yet. I have to get rid of that squared sign. So I have to take the square root of C squared to get rid of that squared sign and just get left with C. And I have to do the same thing to the other side to keep it equal. So the square root of 25 is 5, and the square root of C squared is C. So in this example, C equals 5 inches because both of our legs were in inches. So therefore the C would also be in inches. So C, or our hypotenuse, the longest side, is 5 inches. One way you can check this is C should be longer than the other two sides. So my other two sides were 4 and 3, but my hypotenuse has to be the biggest, 5. 5 is bigger than 4 and 3, so it looks good. Alright, so for our next example, first write our equation, our Pythagorean theorem. Next, I have to label my points. So I know the side across from that right angle is C. I don't know what it is, so I just plug into my equation as C squared. Next, I got to label my A. So my A is going to be 15, and I'm going to write it as 15 squared. Next, I'm going to have B, and I see B is 8, and so put it 8 squared. And then I bring down my plus sign. So I know order of operations tell me I have to do these exponents before I can add. So 15 squared is 225, 8 squared is 64, and then I could bring down my plus sign. I still don't know what c squared is, so I'm just going to bring down c squared. Alright, after I square, I know I can add these two together. So 225 plus 64 gives me 289. I still don't know what c squared is, so I just bring down c squared. But I'm not done yet. I have to figure out what c is, not c squared. So to get rid of that squared, I have to do the square root. And the square root of 289 is 17. So that means c equals 17, or 17 feet, because the other two, a and b, were both feet. Alright, in our next example, start by putting your Pythagorean Theorem, your equation, a squared plus b squared equals c squared. The next thing we have to do is label our sides. So I know the side across from my right angle is c. I don't know what c is, so I can plug that in as just a c. So I have c squared. I know the sides touching my right angle are a and b. So I labeled a, and I can see a is 4. So that would give me 4 squared. And b would be 11. That would be 11 squared. And then I can bring down the plus sign and equal sign. So now I labeled my sides, and I plugged everything in. Now order of operations tells me that I have to do the exponents before I can add. So 4 squared is 16. 11 squared is 121. C squared, I still don't know what it is, so I just bring down c squared. So 16 plus 121 gives me 137. Still don't know what c squared is, so I have to bring that down. Now I have to get rid of that squared sign, so I do that by doing the square root. So I'm left with just c. And then I have to do the same thing the other side to keep it balanced. And the square root of 137 is 11.70469 ... Keeps going on forever and ever because it's an irrational number. So since we have that big long decimal, we can round it to the second decimal place. So I'm going to look at my third decimal place to see if I need to round it up or keep it the same. 5 and above, I give it a shove. 4 and below, I let it go. So it's 4, so I'm going to keep it the same. So it's going to be 11.70 equals c. So my hypotenuse is 11.70 inches. Or another way of saying that is 11.7 inches. 11.7 inches. Remember, c has to be my longest side, so I got to look at my other two. 11.7 is bigger than 11. 11.7 is bigger than 4. So it's the longest side, so I probably did a good job. Alright, if you have any questions, please ask myself or another teacher in the room.